Hello student, myself Digan Sakhiwala, I am your science sir. Today we will continue chapter number 4, carbon and its compound. Dear student, today we are going to learn about the soap and detergent, as well as we will learn about the formation of micelle. To remove the dirt, the micelle formation occur in the soap and detergent, as well as we will learn about the soft water and the hard water. So we will start. Soap and detergent. A soap is the sodium or potassium salt of long chain carboxylic acid which has cleaning property in the water. So soap is nothing but it is the long chain of hydrocarbon which contains COONA group. COONA group is called the head part, and long chain of hydrocarbon in the soap or detergent is called the tail part. Sodium stearate C17H35 COONA is the most common soap used for the domestic purpose. Okay, so we can see that sodium stearate C17H35 COONA is the most common soap used for the domestic purpose. Now dear student, you can see here the C17 are there. This C17 we represent by zigzag line. Okay, this zigzag line we will represent each end and each corner. We can say that it is the CH2. Okay, so in that way we shortcut, in that we represent the C17H35 COONA. This part we can say that it is called the head part, and it is the hydrophilic part. Hydrophilic part means what? It is attracted towards the water. Why it is attracted towards the water? Because water is H plus and OH minus, and this part is also the COO minus and Na plus. So polar compound like polar compounds. Now dear student, what is polar compound? Polar compound means which has charge. So COONA here, it has minus charge, and Na has plus charge, and water has H plus and OH minus. So this part attract the water, so it is called the hydrophilic head. Same way this part we can see the tail part are the zigzag line, that is carbon CH2 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 COONA. This tail part are there, they are made up of hydrocarbon compound, so they are non-polar compound. Non-polar compound means they have no charge. We can say that it is a covalent bond, so no charges are there, so they are non-polar compound are there, and they made by the tail part is made by the covalent bond. They have no charge, so they are repelling the water. So this part is, we can say that, hydrophobic part. So this is the hydrophobic tail. Okay, instead of writing this long chain, we can also represent this thing by the zigzag line. Each end and each corner indicate that carbon is present, CH2 unit is present. The water soluble part, which is ionic, is called the hydrophilic end. Okay, so we can say that the water soluble part which is ionic is called the hydrophilic end. So this part is the, we can say that, hydrophilic end, this COONA, or in the case of SO3Na detergent, this part we can say that it is what? Hydrophilic end, which are attracted towards the water. The water insoluble part is, which is non-ionic, is called the hydrophobic end. So this part we can say that is the hydrophobic end. Detergent, a water soluble cleansing agent which combines with impurities and dirt to make them more soluble, is called the detergent. So when there is a difficult to remove the dirt by the soap, then what we are using? Detergent. What is the basic difference between the soap and detergent? Soap, in that sodium salt of carboxylic acid is present, whereas detergent, in that sodium salt of sulfonic acid is present. Okay, these are generally alkyl benzene sulfonate. So we can say that it is the alkyl benzene sulfonate. Okay, so this part here, SO3Na part, is that is the hydrophilic part, and the other long chain are there. This long chain are there, that long chain is what? Hydrophobic part. Hydrophobic part means it is away from the water, it repel the water, this part attract the water. Cleansing action of soap. Now on our cloth there is a dirt or oil droplets are there, and we try to remove by the water. Whenever we try to remove by the water, this oil droplet is made up of covalent bond, and water is what? Polar bond. Water, in that plus minus charges are present, like H plus and OH minus, and the oil are there, oil, grease are there, they have no charge. So whenever we try to wash the clothes by using simply water, then we cannot remove the dirt, because water has charge and the dirt has not charge. So what we use? We use the soap in that, or we use a detergent. Soap or detergent, in that this part are the zigzag line are there, they have no charge, so it is attached with the oil Okay, here this zigzag line, they attach with the oil. Okay, so this soap and detergent in the zigzag tail part are there, they are attached with the oil, and the head part are there, COONA here, COONA, they have charge, so they are attached with the water. Okay, so they are attached with the water. Okay, because this COONA part is that is the hydrophilic part. COONA has charge and water has also charge, so it is attract towards the water. Like that we can see that the head part is connected with the water and tail part is connected with the oil or the dirt or the oil or droplet. Okay, so when we pass water forcefully, then this star like arrangement push out the dirt and we can remove the dirt from the cloth. This type of arrangement is called the Micelle formation. Okay, whatever star like arrangement are there, tail part of the soap or detergent is attached with the oil and droplet, oil and the dirt, and it makes the star like arrangement, that is called the Micelle formation. Okay, now same way in the detergent what happened, instead of COONA, SO3Na part is connected here, SO3Na. If we use the soap, then these arrangement are there, but if you use the detergent, then SO3Na part combined here, and when we pass the water forcefully, then what happens, this Micelle formation occur, and when we pass the water forcefully, then the dirt is come out. Dear student, we are going to learn about the soft water and hard water. Soft and hard water. Soft water easily generate the leather foam with the soap. Okay, so we can say that soft water easily generate the leather foam with the soap. So whenever we try to clean the clothes or wash the clothes, at that time the foam is produced, that is most important, but some water are there in the foam is not produced. Okay, why? Because what, that water is what, hard water. Okay, so the water in that foam is produced. Soft water easily generate the leather or foam with soap. Hard water contains the salt of calcium and magnesium. When salt of calcium and magnesium react with the soap molecule, they form the precipitate instead of a leather. Foam is not produced. So whenever we try to wash the clothes in the hard water, then the foam, we can say that foam is not produced. Okay, because what happened, the hard water contain calcium and magnesium, and this calcium and magnesium react with the this part of the soap, and because of that reason precipitation occurred. It formed the precipitate instead of foam, and because of that reason we cannot remove the dirt. In hard water, Ca2 plus and Mg2 plus ion replace the Na plus from the fatty acid salt in the soap and make water insoluble fatty acid, thus the prevent the formation of foam. Okay, so we can see that when we use the soap here, then what happened, hard water in that calcium and magnesium are present, that remove the Na plus ion, and instead of Na plus ion, what will connected with them, it is connected with the calcium and magnesium, and because of that reason the foam is not produced. We get the precipitate of this part. Okay, so we cannot clean the clothes when the hard water is present with the soap. Dear student, fatty acid means long chain of acid. Okay, so long chain of carbon acid is called the fatty acid. So we can take the example here. Sodium stearate plus CaCl2 gives C17H35COO2 Ca plus 2NaCl. Okay, so concentrate here in the reaction 2 mole of C17H35COONA, that is called sodium stearate. Okay, this is the example of, we can say that it is the example of soap, in that if calcium is present, then this COONA has tendency to react with the dirt, but when the calcium is present in the water, at that time this calcium will replace the Na. Okay, so it make the calcium salt of soap, so it make the calcium stearate plus 2 mole of NaCl, so it cannot react with the dirt and precipitation reaction occurs. So okay, and so the foam is not produced. Same way, 2 mole of C17H35COONA sodium stearate react with magnesium sulfate, it gives C17H35COO twice Mg plus Na2SO4. Suppose we use the soap, okay, and in that magnesium is present, Mg2 plus form, then C17H35COO twice Mg salt is obtained, that is called the magnesium stearate. Okay, and it is insoluble in the water, and because of that reason the C17H35COONA will not react with the dirt, but it react with the Mg2 plus ion in the form of MgSO4 and precipitate occurs. So we cannot remove the dirt when we use the soap. So why we will use the detergent? Detergent generally not react with the calcium and magnesium. Detergent is more useful than the soap. So dear student, today we learn about, first thing is that we learn about the soap. Soap in the two part are there. One part is called, we can say that, attracted towards the water, that is called the hydrophilic part, and it is the head part. And we can see that long chain of part are there, that is called the hydrophobic tail. It is the water repellent, it is not attracted towards the water, so it is called the hydrophobic tail. Detergent, in that sodium salt of sulfonic acid is present, okay. And when we want to remove the dirt, at that time micelle type formation occur, and this micelle type of formation occur in the soap. Soap, in that COONA group is present. Suppose we use the detergent, then here SO3Na group is present. Same way we learn about the soft water and the hard water. Soft water, in that foam is produced, hard water in that foam is not produced. Only reason is that hard water in that calcium and magnesium salt are present, and calcium and magnesium salt are react with the soap and precipitation reaction occur, so foam is not produced. So this is all about the today's portion. Thank you so much.